Hello to anybody that's listening to this right now. In this video, I'm now going to be discussing about the subtopics, system of equations, and consistent and inconsistent systems. In my previous video, I was discussing about the subtopics, intersection of lines in R2 and R3, and intersections of lines and planes in R3. So if you have not watched that video yet, please go back right now to watch it. But without further ado, let's get started on this video. All right, moving on from where I last left off in my previous video, I will now be talking about the system of equations, which is more or less the algebra reviews. Within this syllabus that we are teaching, there are two cases. The first case is in which I have shown below is two equations and two unknowns. And the second case is, as also shown below, three equations and three unknowns. I will also bring up the consistent and inconsistent systems. To those who may not know, a consistent system is basically there can be at least one solution, or there can be up to an infinite amount of solutions. Whereas for inconsistent system, there should not be any solutions at all. All right, so now we're going to be talking about the first case, which is the two equation and two unknowns. Here's basically an example to show what it basically means. So let's start it off with two equations. 2x plus 4y equals to 8. And the second, let's just say x minus 4y equals to 10. If you basically add them together, it will be, by adding the x's and y's and other values, it will basically become 3x equals to 18. So we simplify it, x will become 6. And then through this, we can find out the value of y by adding the value of x into the equation. So 6 minus 4y equals to 10. And basically negative 4y equals to 4. So y would be equals to negative 1. So having both the values of 6 of x as 6 and y as negative 1, we can tell that there is at least one solution within this. So this means that the system is consistent. Now here is another solution, another example. It's still, to those who are confused, it's still basically the second two equations and two unknowns. But this is just another example. Another example I'm showing is basically 2x plus 4y equals a. And the second equation would be x plus 2y equals to 4. So simplifying this, simplifying the second equation, we can tell that x will be equals to 4 minus 2y. So we add, knowing the value of x, we can basically add it into the first solution. So 2 times 4 minus 2y plus 4y equals to a. A equals to 4y plus minus a equals minus 4y plus 4y equals to a. So this means that 0y equals to 0. This means that there is there is basically an infinite solution for both x and y. This means that the system is consistent. All right, now I'm going to show you an example of when the system would be inconsistent. So here's one last example. X minus 2y equals to 4. And negative 2x plus 4y equals to 8. So, like just now, we simplify it a bit. X would be equals to 4 plus 2y. So we add it into the other equation. Negative 2 times 4 plus 2y plus 4y equals to 8. So negative 8 plus 0y equals to 8. So 0y will be equals to 16. This means that there are no values of y. Hence, there will be no solution whatsoever, which means that ultimately this whole system would be inconsistent. And that would basically be it for all my examples for the case of 2 equations and 2 unknowns. Moving on to our next case, which is 3 equations and 3 unknowns. I will be showing a couple of examples to help you guys understand better. So the first example, I will provide 3 equations: x plus y plus z equals to 0, x minus y equals to 1, y minus z equals to -5. Using these equations, we can also simplify to find some values. So x equals 1 plus y, in which we use the second equation to find out. And to find out the value of z, we're using the third equation, which is z equals to y plus 5. So with these values, we can insert it into the equation to find out. So this, if you don't know, this process actually called simultaneous equation. So 1 plus y plus y plus y plus 5 equals to 0. Simplifying it, 3y would be equals to 6. Hence, y would be equal to -2. And because we know the value is -2, we can go back to the values, and we can see that x equals to 1 plus -2 equals to -1. And for z, it would be -2 plus 5, in which the value will be 3. So because each of them has different values, and since we found out all the values of each of x, y, and z, we can tell that there is only one solution. Hence, the system is consistent. now for another example, example 2, just like earlier, I will also be giving 3 equations. X minus 2y plus z equals to 0. X minus y will be equal to 1. And y minus z equals to 1. Just like just now, we'll also simplify it. X equals 1 plus y from the second equation. Z would be y minus 1, which we got from the third equation. So with these values, we move it back to the first equation. 1 plus y minus 2y plus y minus 1 equal to 0. Simplifying it further, we will ultimately get 0y equals to 0. This means that it will be an infinite solution. And hence, the system will be consistent. All right. I'll be giving one final example for this case, which is, so starting an example, I will it's also once again 3 equations. So let's just say x minus 2y plus z equals to 2. X minus y will be equal to 1. Y minus z will be equal to 1. So like the other 2 slides, it will be x equals to 1 plus y from the second equation, and z will be y minus 1 from the third equation. So finding these values, we move back to the first slide. 1 plus y minus 2y plus y minus 1 equals to 2. We will find out that after simplifying, the 0y will be equals to 2. Hence, there will be no values of y. This means that there is no solution whatsoever, and therefore the system will be inconsistent, unlike the other 2. And that will be all for me talking about the system of 3 equations and 3 unknowns. Anyways, that will be it for this video and for my part as well. I will let my partner Zicheng handle the remaining subtopics with you guys. Once again, good luck with your homework and assessments. Thank you and have a nice day.